So in today's video, we are going to learn how to resolve a force into two components acting along the x and y axis. These components are called the rectangular components of the force. There are two ways in expressing these components. We can have either the scalar notation or the Cartesian vector notation. However, in this video, we are going to focus more on the scalar notation. So let's consider a force, say F, acting at an angle of theta degrees to the positive x-axis. Now from the force, let's draw a line parallel to both the x and y axis. Now the force acting along the x-axis is called Fx, that is the horizontal component of the force F. And the force acting along the y-axis is called the vertical component of the force F. Now Fx can be found by multiplying the force, that is the resultant force, by cosine of the angle theta, and then Fy is also equal to F sine theta. Now the resultant force F is equal to the square root of Fx squared plus Fy squared, and the angle theta is equal to tan inverse of the vertical component divided by the horizontal component. So now let's consider a situation where theta is not given. However, we have a small slope triangle. Now using the small slope triangle, we can as well find Fx and then Fy. So let's consider a force F acting this way, and then this is the positive x-axis. We have positive y-axis, negative x-axis, and then negative y-axis. Now let's draw the two parallel lines. So we have this, and then we also have this. So the force acting along the x-axis is Fx, and the force acting along the y-axis is Fy. And then we have F, the resultant force. Now we have a small slope triangle here. Now we have the longest side, that is the hypotenuse, to be C. We have this side to be B, and then we have this side to be A. Now let's focus on these two formulas. For Fx, we have Fx equals F cos theta. So we can divide through by F, and then we have Fx over F equals cos theta. And then we also have Fy divided by F equals sine theta. So we are going to use these two here in this diagram. Now for Fx, we have Fx over F, that is equal to, now let's compare. Fx corresponds with A because they are all moving along the same line. So Fx equals A over, and then we have F corresponding with C because they are also moving on the same line or along the same line. So we have divided by C. Now we can cross multiply and then make Fx the subject. So we have Fx equals A over C, and then we multiply by F. So this is the formula for Fx. Now let's do same for Fy. So we have Fy divided by F, which is equal to, now Fy corresponds with B, so we have B divided by C. So we have Fy equals B over C times F. However, we realize that Fy acts on the negative y-axis, so it means that you have to include, or you have to attach negative to this formula. So we have Fy equals negative B over A times C. For Fx, Fx was lying on the positive x-axis, so we do not have any negative attached here. However, for Fy, because it is acting on the negative y-axis, we should attach negative to it. So if you don't have theta, you can as well use the small slope triangle to find fx and then fy. So now let's solve some examples. Let's take our first example. So for question number 1, we are to determine the magnitude of the resultant force and the angle it makes with the positive x-axis. Now we have two forces, F1 that is 600 newtons and then F2 400 newtons. Now F1 makes an angle of 30 degrees with the positive x-axis, and we have F2 making an angle of 45 degrees with the positive y-axis. However, when solving problems like this, let's always make sure that we take our reference point from the positive x-axis, that is, with reference to the angle. So let's see how we can represent the forces and the angle away from the positive x-axis. So for F1, we have 600 newtons and then it makes an angle of 30 degrees with the positive x-axis. So we have 0, 30 degrees. Now for F2, we have F2 to be 400 newtons, and then from this axis, that is the positive y-axis, to the positive x-axis, we have 90 degrees. So 90 plus 45 is 135. So this force F2 makes an angle of 135 degrees with the positive x-axis. So we have 135 degrees. So now let's find the vertical and horizontal components of the forces F1 and F2. So for F1, F1x is equal to 600 cos 30, and then 600 cos 30 is 519.62 newtons. Now let's find F2x. Now F2x is 400 cos 135, and then that is equal to negative 282.84 newtons. Now let's find F1y. So F1y is 600 sine 30. So we have 600 sine 30, and that is equal to 300 newtons. And then we have F2y, which is equal to 400 sine 135, and that is also 282.84 newtons. Now let's find Frx and then Fry. So Frx is equal to F1x plus F2x. So F1x is 519.62, and then F2x is negative 282.84. So Frx is equal to 236.78 newtons. Now let's find Fry. So Fry is equal to F1y plus F2y. So F1y is 300 newtons, and then F2y is 282.84 newtons. So when we add them, we get 582.84 newtons. So that is for Fry. So let's find the resultant force Fr. So Fr is equal to the square root of Frx squared plus Fry squared. So we have the square root of Frx is equal to 236.78 squared plus 582.84 squared. So we have the resultant force to be 629.1 newtons. Now let's find the angle theta, the angle the resultant force makes with the positive x-axis. So we have the x-axis, we have the y-axis, and then we have this force, that is Fr equals 629.1 newtons. And now because we have positive values for Frx and then Fry, it means that we have our diagram in the first quadrant. So this is Fry, and then this is Frx. So this is our angle theta, and then we are going to find theta. So theta is equal to tan inverse of Fry over Frx. So we have Fry to be 582.84, and then we have Frx to be 236.78. So tan inverse of this whole thing is equal to 67.9 degrees. So we have our theta to be 67.9 degrees. So now let's solve the second example. So for the second example, we are also going to determine the magnitude of the resultant force and the angle it makes with the positive x-axis. So here we have three forces. We have F1 300 newtons, we have F2 450 newtons, and then we have F3 600 newtons. Now let's write the forces and the angle they make with the positive x-axis. So for F1, we have F1 to be 300 newtons, which makes an angle of 90 degrees with the positive x-axis. So we have 090 degrees. Now for F2, we have a force of 450 newtons. Now from this point to this point, we have 90 degrees, and then if here is 45, we also have 45 here. So 90 plus 45 is 135. So we have 135. And for F3, we have 600 newtons, but we don't know the angle as at now. So let's find the x components. So F1x is going to be 300 cos 90, and 300 cos 90 is equal to 0. Now F2x is equal to 450 cos 135, and that is equal to negative 318.2 newtons. Now for F3x, we have F3x divided by F, and that is equal to, now let's draw F3x and then F3y. So this is the force F3, so this is going to be the y component, and then this is going to be the x component. So we have F3y and then F3x. Now F3x corresponds with 3, because here we don't have the angle, so we are going to use the small slope triangle. So F3x corresponds with 3, so we have 3 here, and then F, which is the force, corresponds with 5, the hypotenuse, so we have 5. So now to find F3x, we have F3x equals 3 over 5 times the force F3. Now F3 is 600 newtons, so F3x is equal to 360 newtons. So now let's find Frx. So Frx equals F1x plus F2x plus F3x. Now F1x is 0, F2x is negative 318.2, and then F3x is equal to 360. So when you sum them up, you are going to get 41.8 newtons. So so that is frx. So let's find for fry. So for fry, let's find f1y. Now f1y is equal to 300 sine 90, and that is equal to 300 newtons. And then we have f2y equals 450 sine 135, that is equal to 318.2 newtons. And then we have f3. Now we have f3y divided by f equals, now let's visit the diagram. So f3y corresponds with 4, so we have 4 divided by f, which corresponds with 5, so we have 5. So f3y is equal to 4 over 5 times f3. Now f3 is 600, so that is 480 newtons. So fry is equal to f1y plus f2y plus f3y, and that is going to be 300 plus 318.2 plus 480, and the answer is 1098.2 newtons. So we have Fr, that is the resultant force, to be the square root of Frx squared. So we have 41.8 squared plus Fry squared, that is 1098.2 squared. So Fr is equal to 1098.99, which is equal to 1099 newtons. So this is the resultant force. Now to find the angle theta, we have theta equals tan inverse of 1098.2 divided by 41.8, and then we have theta to be equal to 87.82 degrees. Let's solve the third example. So for the third example, we have three forces. We have F1 400 newtons, F2 250 newtons, F3 200 newtons, and we are going to find the magnitude and direction of the resultant force. So let's write the forces and the angle they make with the positive x-axis. So for F1, we have 400 newtons, and then it makes an angle of 0 degrees with the positive x-axis. So we have 0 degrees. Now for F2, we have 250 newtons, which makes an angle of 45 degrees with the positive x-axis, because 90 minus 45 is 45. So we have 0, 4, 5. And then for F3, we have 200 newtons, and then the angle was not given. Now let's analyze the three forces. You realize that F2 and then F3 are acting away from this point. However, we have F1 acting towards this point. So if F2 and F3 are positive, then F1 is going to be negative. So instead of having 400 newtons, we are going to have negative 400 newtons. So we have F1 to be negative 400 newtons and then 0 degrees. So let's find the horizontal components, that is Frx. So we have F1x to be negative 400 cos 0, and that is negative 400 newtons. We have F2x to be 250 cos 45, and that is 176.8 newtons. Now for F3x, we have F3x divided by F3 equals, now this is F3, so let's draw the x and y components of F3. So we have F3x and then f3y. Now f3x, this is f3x, corresponds with 4. So we have 4 divided by f3 corresponds with 5, the hypotenuse. Now you realize that f3x acts on the negative x-axis. So we have negative 4 over 5, and then f3x is equal to negative 4 over 5 times f3. Now f3 is 200 newtons. So negative 4 over 5 times 200 is equal to negative 160 newtons. So frx is equal to negative 400 plus 176.8 minus 160, and then that is equal to negative 383.2 newtons. That is frx. So now let's find the value of fry. So f1y is equal to negative 400 sine 0. Now that is equal to 0 newtons. We have f2y equals 250 sine 45. That is equal to 176.8 newtons. And then we have f3y over f to be equal to, now f3y corresponds with 3. So we have 3 divided by 5. Now because f3y is lying on the positive y-axis, we don't attach any negative to this. So f3y is equal to 3 over 5 times 200, and that is equal to 120 newtons. So fry is equal to 0 plus 176.8 plus 120, and that is equal to 296.8 newtons. So Fr, the resultant force, is equal to the square root of negative 383.2 squared plus 296.8 squared. So we have Fr to be equal to 484.7 newtons. So this is the resultant force. Now let's find the angle the resultant force Fr makes with the positive x-axis. So we had Frx to be negative 383.2 newtons, and then we had Fry to be 296.8 newtons, and then the resultant force was 484.7 newtons. So let's represent this on a graph. So we have a negative value for Frx. So that's going to lie on the negative x-axis. So this is Frx, and then we have a positive value for Fry. So this is Fry, and then we have the force Fr. Now let this angle be alpha, and let's try to find alpha. So alpha is equal to tan inverse of Fry over Frx. So we have alpha equals tan inverse of 296.8 divided by 383.2. So when finding the angle, you can ignore any negative sign. So we have alpha to be equal to 37.8 degrees. Now our interest is to find the angle the resultant force makes with the positive x-axis. So if from this point to this point is 180 degrees. Then theta is equal to 180 minus alpha. So we have 180 minus 37.8, and that is equal to 142.2 degrees. So this is the angle the resultant force makes with the positive x-axis.